These are the trigonometric derivatives. So if you look at like the derivative of sine is cosine, derivative of cosine is negative sine, and so on. So these derivatives you do need to memorize. There's never a chart given to you when you're testing or anything like that. So whatever way you need to memorize them, just memorize them. So the ones that we use the most are, the derivative of sine, cosine, and tangent. However, they do all come up. So we're going to go straight to examples because these are relatively simple because we're just applying these derivatives. So this is our first example. Calculate f prime of x, where f of x is x times cosine x. So you'll see there's a little red dot between x and cosine. So we're going to apply the product rule first. So if I take the derivative, it would be u prime, and so u is here, v is here. So u prime is 1 times v, and we're going to add that to x times the derivative of cosine, which is negative sine. I think I switched the order of the product rule, but it doesn't matter. And then we just simplify that. So this will be cosine x minus x sine x. So not a whole lot to it. We just apply the rules. So in this next example, we're going to verify that one of the trig derivatives is what we said it was. So the derivative of tangent is secant squared. And so we can't just, say it is what it is. We have to find a way to get there. So you'll see I have the quotient rule in green there. And that's because I'm going to take my function tangent and I will rewrite it as sine over cosine. And then we have something that is a quotient, and we'll say u is sine and v is cosine. And now let's take the derivative. So the derivative of u is cosine, and then it says multiply by v, which is cosine. Then subtract the derivative of v, so negative sine, and multiply that by u, which is just sine, all divided by v squared or cosine squared x. Now we simplify. This needs to match secant squared x, so we get cosine squared x plus sine squared x over cosine squared x. Okay, so I know that I don't want to split that fraction apart. I want to apply the Pythagorean identity. And so then I can rewrite this as 1 over cosine squared x. And that used the reciprocal identity there. So what we end up with is secant x, secant squared x. So it has been verified. Okay, so in this one, this is doing something we've been doing for weeks. So we're going to find a tangent line to a graph at a point. It just so happens that it has trig functions. So we have tangent times secant, and I've already labeled that as u and v because that's a product. And so we'll just apply the product rule to this. So if we have y prime, it's going to be the derivative of u. So that is the derivative of tangent is secant squared times v. V is secant. And then we're going to add that to v prime, which is secant tangent multiplied by u, which is tangent. Okay, so I will multiply this out, kind of clean it up. So secant cubed theta plus secant theta tangent squared theta. Okay, so that is my derivative. Now what I want to do is evaluate that derivative at pi over 4. So I go y prime of pi over 4 equals secant of pi over 4. I'm going to write this differently just so I can clearly see what I'm doing. Plus secant of pi over 4 times tangent of pi over 4, and that's squared as well. Okay, so now I just need to remember what secant of pi over 4 is and what tangent of pi over 4 is. So secant of pi over 4 is root 2. And then tangent of pi over 4 is 1. So then that's a relatively easy derivative. So what we're going to get is root 2 times root 2, which is 2, times root 2. So we're going to have 2 root 2 plus root 2, or 3 root 2. So y prime of pi over 4 is our slope. So if you remember, I like to write these in point slope form. And so this is our m value. Okay, so what's our point? Well, our x value is pi over 4. And then to find our y value, we're going to say y prime of, oh, not y prime, just y of pi over 4. So that would be tangent of pi over 4 times secant of pi over 4. So y of pi over 4 is going to be 1 times root 2. So this would just be root 2. So that is our y value. So if I plug all this in, I have y minus my y value, which is root 2, or equals m, which is 3 root 2, times x minus my x value, which is pi over 4. So that is the tangent line to the graph at pi over 4. And I do see a little mistake there. I've been using x's because I'm used to it. This is a theta.